access technique, that is OFDM, orthogonal frequency multiple access, OFDM. Orthogonal frequency division multiple access. Anyway, before learning what is meant by orthogonal frequency division multiple access, let us know what is meant by FDM, frequency division multiplexing. What is frequency division multiplexing? What is orthogonal frequency division multiplexing? What is orthogonal frequency division multiple access? So before learning what is meant by OFDMA, it is better to learn about FDM, OFDM, and after knowing a little bit of FDM and OFDM, we will learn about OFDMA. Because by comparing FDM with OFDM and OFDM with OFDMA, it is very easy to understand what is meant by orthogonal frequency division multiple access, right? So let us learn briefly about frequency division multiplexing, that is FDM. So FDM allows a multiplexing method. Okay, FDM is a multiplexing method used to divide a channel into many non-overlapping subchannels. Okay, you have to keep in mind that FDM means dividing into non-overlapping subchannels. And FDM allows multiple users to share one single link. Know what is meant by a multiplexer? Some n number of inputs, and at a time only one input is used to access the respective channel, right? So n number of inputs, there is only one output. In a similar way here also, multiplexing method used to divide a channel. We are dividing a channel into many non-overlapping subchannels, and it allows only multiple users to share a single link. Users are many, and these multiple users will only share a single link. There is only one link to share. So this is about the representation of different signals. Okay, with respect to FDM, this is the time. We are dividing the frequency. Okay, and allocating one signal at one respective channel. We are dividing the channel. Next, here in FDM, a guard band is inserted. Okay, that is a narrow frequency range is inserted between adjacent channels so that different signals travel separately and simultaneously without interfering with each other. Okay. So during transmission, okay, in FDM, guard bands are inserted between different signals. See, here each signal shows different colors. Different colors means different signals. Okay. Here the red color mark indicates the guard band. We are inserting a guard band between the two different signals. Guard band is inserted between adjacent subchannels so that different signals travel separately and simultaneously without interfering with each other. So in order to avoid the interference, here in FDM we are inserting the guard bands between different signals. Okay, that's one point with respect to it. This is about brief explanation about frequency division multiplexing. Next, go to OFDM. So learn about frequency division multiplexing. Okay, there the guard bands are inserted between different signals, not to avoid the interference. Of course, even though the guard bands are inserted here, it occupies more bandwidth. More bandwidth is occupied. In FDM, so we can say that the occupation of bandwidth is more in FDM as a disadvantage. So coming to OFDM, orthogonal frequency division multiplexing, is a very popular multiplexing method used for latest wireless technologies and telecommunication standards such as Wi-Fi 802.11 AC, 4G communication and 5G communication, WiMAX. Okay, WiMAX is worldwide interoperability of microwave access, right? The satellite and many others. So in OFDM, these subchannels are closely spaced I am repeating here, the channels, you can see the figure, the channels are closely spaced. Here in FDM, we have inserted the guard bands between the respective channels. Right. Insert the guard band between the respective channels of different signals. Here, these are closely spaced only, and no guard band is between them. This is the highlighted point. No guard band is between them, but actually they are overlapped. Okay. Here we have taken the signals closely. Okay. Here they are separated. And guard band is inserted. Guard band is inserted in order to avoid the interference. Here we have combined all the signals in orthogonal frequency division multiplexing. Then how? Here the point is how we are avoiding the interference. How we are avoiding the interference between the channels. So with the same available bandwidth, OFDM would allow more data transmissions than FDM. Here in less bandwidth, we are transmitting more number of channels. So we have sufficient available bandwidth. So we can transmit more number of channels. Okay. So here bandwidth is saved, and within the available bandwidth, we can transmit more number of channels. So that is the point. The same available bandwidth, OFDM would allow more data transmissions than FDM. Okay. This is the comparison between FDM and OFDM. Let us suppose there are three different signals to send over one shared channel. Okay. Let us suppose there are three different signals to send over a common channel. So an OFDM would combine them closely together in a way they are orthogonal to each other. Okay. In a way they are orthogonal to each other. So there is a pink signal here, blue signal here, and there is a yellow signal here. Just I am representing in the name of color. Okay. So and three signals have different frequencies. Okay. And we are transmitting them in a channel, and they are orthogonal to each other like this. Okay. Anyway, by examining this respective figure, you can come to a conclusion that in the three signals, that is pink, blue, and yellow, that when the signal reaches its peak, okay, peak means this is the peak. For example, blue, for the blue signal, this is the peak point. This is said to be the peak point. Okay. The highest point and the other two neighbors are at their 0th point or at null. Okay. So one signal is at peak point and the yellow and the pink signal are at null. If you take this one, the pink signal is at the peak point. Okay. And at the same time here the blue and yellow signal are at null. If you take the yellow signal, here yellow signal is at peak point and the blue and pink signal are at null. It states that there is no interference between the respective channels. So one is at peak, other two are at null. Pink is at peak, other two signals are at null. Yellow signal is at peak, other two are at null position. So it states that there is no overlapping between the signals. Such a way they are orthogonal to each other. See here orthogonality means signals are multiplexed in a way that the peak of one signal occurs at null of the other neighboring signals. Peak of one signal occurs at the null of the other two signals. So since the other two signals are at, since we have taken only three signals, okay, this is the position. Okay. We can take n number of signals for better understanding. Not understand the concept, we are representing only three signals here. That is n by orthogonality. And at the receiving end, so there is a transmitting end. Without interface, we are transmitting the channels. So the receiving end, the demodulator would separate them based on their orthogonal feature, and OFDM would better utilize available bandwidth, thus offering higher data transmission rate than FDM. So within the less bandwidth, we can transmit more number of channels. So by using a demodulator, we can separate the respective signals. Okay. This is about OFDM. So kindly make down the difference between FDM, guard bands are used, in OFDM, no guard bands are used. FDM not avoid the interference. In FDM have used the guard bands. Here in OFDM we are using the orthogonality, means one is at peak, other respective signals are at the null position. In such a way we are transmitting the signals and we are using the respective demodulator not extract the respective signals, right? And we are saving the bandwidth, and bandwidth is utilized effectively. Next, coming to OFDMA, that is orthogonal frequency division multiple axis. OFDMA is a feature of Wi-Fi 6, that is 802.11 AX. Remember, OFDM is 802.11 AC. OFDM is 802.11 AC and OFDMA is 802.11 AX. That allows access points to serve multiple clients. At the same time. This is the main feature. Here it is serving multiple clients at the same time. This is the main point we have to remember. Not a single client. In OFDM, single client is served at a time. Okay. Here, multiple clients are served at a time with respect to time. So OFDMA follows a set of rules created for the transmission of data between more than one terminal, that is any device at the end of transmission channel such as computer or phone, or a transmission medium such as wireless network. So you can represent a figure. OFDM is a multi-user version of OFDM, nothing but advanced version of an OFDM that allows multiple users. In OFDM, only a single client is used. Multiple users to share the available bandwidth and transmit simultaneously. Simultaneous transmission is there with respect to time. See the figure. Okay, here all tones are assigned to a single client. Here it is using OFDM only. Okay, and but only one single client is assigned. But in OFDMA, there are n number of clients we can assign simultaneously. Client 1, client 2, client 3, client 4, client 5, client 6. Okay, represented by different colors. So this figure represents the difference between OFDM and OFDMA. See, my intention is by comparing the FDM to OFDM and OFDM to OFDMA, we can exactly know the advantages of the OFDMA with respect to FDM and OFDM. So that's my point. So that's why I am comparing FDM, OFDM and OFDMA. That's how we can learn about OFDMA in a better way. So here also the conclusion figure shows the difference between OFDM and OFDMA. In OFDM, you can see that there are 3 users. So with respect to time, here only user 1, the blue indicates only user 1 in different frequencies with respect to time. And user 2, different frequencies with respect to time. And user 3, here the frequency division, only single user is used with respect to time. Okay, this is user 1, user 2 and user 3. Okay, this is OFDM, that is 802.11 AC. At the given time, a single user gets the full bandwidth. Only the single user, that is user 1, will get the full bandwidth, independent of packet size, and each device waits its turn to transmit. So while user 1 is transmitting, user 2 and 3 waits. Okay, while user 2 is transmitting, user 3 waits, and user 3 transmitting, user 4 has to wait. Of course, here we are using the orthogonality, and by overlapping the signal, by maintaining the signal one at peak point and other at the null, we are transmitting the signal and saving the bandwidth in an effective way in OFDM. But coming to OFDMA, here only single user is used at a point. Here multiple users. If you see with respect to time, here user 1, user 1, user 1 and user 2. So in simultaneous transmission is there in OFDMA. So here with respect to time, user 1, user 1, user 1, user 2, user 1, user 1, next here it may be some user 3. Okay, blue is the user 1, and the light blue indicates the user 2, and the green indicates, let it be user 4, or it is not using, we are not using anything, only user 1 is used, 1 and 2 are used, only 1, 2 is used with respect to time. only user 3 and 1, only user 2 and 3, like that. With respect to time, the simultaneous transmission takes place in OFDMA. Okay, that's the difference. So here also this figure, it indicates different clients in OFDMA. Single client in OFDM, single client, only blue, only user 1 in OFDM. Multiple clients, client 1, client 2, user 1, user 2 in OFDMA. So indicates that at a given time, multiple users share the available bandwidth up to 9 users in a 20 megahertz channel. Okay. So this is what is meant by OFDMA. Okay. Here my intention is first by telling the differences. Okay, by telling the difference between frequency division multiplexing, orthogonal frequency division multiplexing, and orthogonal frequency division multiple access. Okay, it is better way. It's a better way to learn about the concept OFDMA. Okay, thank you.